Hello, welcome everyone. In this video, we are going to learn how to find a parallel line to a given line passing through a certain point. So let's start with our first example. All right. So for a line to be a parallel, we should know that the two lines should have the same slope. So the slope of the two lines have to be same. So m1 equals m2. So we are given an equation of a line, and we are required to find a line that is parallel to this line but passes through this particular point. So from the given equation, we already know the slope of the line is 2. So I'm going to change this h of x, a function, to like a more standard form, that y equals 2x minus 1. So this is like the slope-intercept form, okay? And from a function form, we brought it into just a generic form that we are very familiar with. So now we know that this is the m of our given line and this is the b. So m1 equals 2. From this we know that the line that we're trying to find, which is parallel to this line, should also have the same slope. So the m2 must be equal to 2 as well. So now we go ahead and actually write this equation, y equals mx plus b. Okay, this is the slope-intercept form. And then what we do next, we plug in the slope value, 2x. So for m, we plug in 2 and leave the x there, plus b. Okay. Now we have this equation where we still have one unknown to find, which is thus the intercept, the y-intercept. For this particular purpose, we use this point that is given to us, which is 2, 6. This is the x value and this is the y value. So we take this point and we plug it into this equation and we go ahead and solve for the b. So we know that y is 6, 2, in parentheses, the x value is 2 plus b. So 6 equals 4 plus b. And now it's just a simple equation that we can solve. We subtract 4 from both sides. And you have b equals, this is gone, 0. And you add these two, so b plus 0 equals 2. And that means b equals just 2 because 0 doesn't have any value. So now we can plug this 2 right here. So y equals mx plus b, and now we plug in both the slope and the y-intercept. So the slope is 2, so 2x, plus the y-intercept is 2 right here. So this is the equation of the line which is parallel to this line and is passing through this point right here. All right, so the main thing is, when you're trying to find a parallel line to a given line, make sure you know that the slope of each of these lines is going to be the same. So the slope of the first line that is given to you is equal to the slope of the line that you're trying to find the equation of. So m1 is equal to m2. All right, let's do the next example. Here we're trying to find the same thing, finding an equation of a parallel line which is parallel to this equation and passing through this point right here. So we go ahead and use our prior knowledge that the slope of the two lines have to be same. So first line is g of x. I'm going to change that into a y equals negative 4x minus 4. Okay. So this is the slope-intercept form that we are familiar with. So y equals negative 4x minus 1. This is your slope and this is b, the y-intercept. So m equals negative 4, m1. Okay, so from here we know that the m2 has to be equal to negative 4 as well. They have to have same slope. So we go ahead and use our slope-intercept form again, y equals mx plus b, and we plug in the value of m, which is negative 4, and x plus b. All I did is substitute the value of m, which is negative 4. And then from here we still have a b, which is unknown. For this one we use the point because this line passes through this point right here, so we can use this point to solve for the b value. So this is our x value and this is our y value. So y is 6 minus 4 and x is 2 plus b. 6 equals, when you multiply negative 4 by 2, you get negative 8 plus b. And then we solve for b, we add 8 on both sides. So you have b plus, when you add 8 and negative 8 becomes 0, equals 14. So now b equals 14. Now we write down our generic form, y equals mx plus b. And then we plug in the values that we know, negative 4 for m and 14 for b. So this is the equation of the line which is parallel to this line and is passing through this point. So these two are parallel lines. Okay, this would be the end of the video, and hopefully this helps. Just practice more to get better at it.